Welcome to Learning Beyond. I'm Anil Mahadik. Today we are going to discuss on the column and footing details which are followed on the site for any building, RCC building. So generally structural consultants gives the standard drawings to us. So we should know how to refer the structural drawing for columns and footings and what are the technical details. And this video is useful for civil engineers who are working on site or civil engineers and structural engineers who are working in the office also in structural consultant office. So it is applicable for both of the engineers. So let's see. So this kind of structural drawing we get as a structural standard drawing where there are column details given regarding the reinforcement, then stirrup details given. There is a footing detail also, section and plans, then structural notes and number of floors given in the drawing, and development length and lap length given. And this is the title block of the drawing. So generally we get such a kind of drawings. So how to read these drawings? So whenever we get the reinforcement details for columns, so the number of bars given are in the other drawings actually generally. In column detail drawings, we get number of bars in the columns. Like let's say this is a column and the consultant has given 8 number of bars. So let's say 820 is the number of bars. Let's say 8T20 is the number of bars. This is the column. Let's say, you know that if you draw the column, then the column may look like this in plan: 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 bars, let's say, and there is a stirrup also. Stirrup, or you can say link also. The different names are there. So let me show this. This kind of link is there in the bar. So there are 8 bars here. So whenever we provide any reinforcement, we need to do the lap also, because whenever we use for high-rise buildings or number of floors are more, then you need to have a lap to the reinforcement. So we cannot provide the reinforcement of the full height. So where should be the lap location? So lap location is generally should be at the center of the column height. So if this is L2 is the height of the column, let's say, then at the center it is L by 2, and L by 2 we will provide the lap. But if you notice this drawing, then we are not providing the 100% lap here. So see, out of these 8 bars, this will be half bars, we can say. So if you see, this is the lap, we will have only 4 bars here, 4T20. So 50% bars below the center line and 50% bars here above the center line. So we are not lapping the bars at one section 100%. And what is the lap length? Lap length is nothing but the LD. And LD depends on the grade of steel and concrete. You can see here. If your drawing is giving M20 grade of concrete and Fe500, then 60 times diameter of the bar will be the lap length, which is 60 times diameter is, so as it is a 20 mm diameter, so 60 into 20 will be 1200 mm. So that LD will be 1200 for that case. So this is the lap location. And this you need to joggle the bar like this. So this joggle will be something, it is generally 1:6 slope actually, as per the structural drawing details. For this case, the consultant has given 200 mm. So this is the generally 1:6 slope for the joggling of the bars. And don't provide the lapping more than 50%. So this is the, if you want the staggered lap, we generally call this system as a staggered lap, where we don't provide more than 50% laps at one location. And you can see this minimum spacing of the stirrups up to L by 4. So L by 4 is the spacing of the stirrups will be very closer as per given in the drawing, because you know that in earthquake condition, there is more shear near the beam column junction. So in that zone, what happens? The shear value in this zone is more. So as it is more in this zone, so we will have more closer spacing of the stirrups. So more steel will be there. So that is the zone you can see, which is L by 4 here. Up to L by 4, the spacing is closer, and then other zone the spacing is maximum as per drawing. Apart from that, for the earthquake detailing, we should provide at least 3 stirrups within the column and beam junction. So you can see this is a beam, this is a column, and this is the beam column junction. So minimum 3 links should be provided. So this links means stirrups. You can use any word. For column, generally we use link as a word. So minimum 3 links should be there, 1, 2, and 3. This link means this link or stirrups. There may be hooks also or loops also, links like this. So within this, we can provide links like this also, like this, to tie the main steel like this. So this is the zone L/4 for the closer spacing of the stirrups. Minimum 3 links in the beam column junction and staggered lap, not more than 50% bars at one location. Lap length LD. Now there is second detail. So if you do want the lap at same location, so as per ACI code, actually they have given this criteria. If you want to provide the lap at one location only, provide lap at center of the height of the column, but the LD should be more. So it should be 1.3 times LD. So this was the case for staggered lap. Now, if you want to use this lap location at 1 point, then 1.3 into LD will be the lap length. So LD is, in the previous case, it is 1200. So 1.3 into 1200. mm. Okay. So this will be 1560 mm lap length. If you want to provide the all the bars lap location at the same point. Okay. So this is, all other details are same like this, only this is the case. So many times site people ask, they are finding difficulty providing staggered lap. In that case, you can give such solutions to them. So this is the column section detail. Now, whenever we provide such as stirrups or links in the column to tie the main bars, then we provide the hook like this. So this hook length should be 75 mm or 10 times diameter of the stirrup, whichever is maximum. So generally nowadays we use the diameter of the stirrup minimum as 8 mm. So if it is a 8 mm stirrup diameter, then your 10 times diameter will be 10 into 8 will be 80 mm. So this hook length will be 80 mm. So this will be 80, and again this will be 80 if it is 8 mm diameter. So these are the earthquake details, hook length we can say for columns, and it is also applicable for beams also. Okay, now we will see the footing details given in the drawing. So in footing, let me remove this. We look at the footing drawing. So this is the plan of the footing. So generally we get the foundation layout in the structural drawing for particular project, where there is a width of the footing and length of the footing in plan. And then there is a depth of footing, D. So we know that whenever footing is having which kind of load, the footing carries axial load from the column like this vertical axial load, and there is a moment also in the footing. So due to that, the footing will bend like this. So let me show the bending deflection diagram. It will bend like this. Cantilever bending moment we can see. So there is a tension at the bottom, and that's why you can see this black color reinforcement. Main steel is at the bottom, like cantilevers. And there is a L also for the reinforcement. And this column reinforcement is embedded into the footing like this. So that's why you can see the in footing we generally have a reinforcement at the bottom because tension is at the bottom. Now let's see how the details are given for this. So if the columns are supported on the footing, So in that case, whatever main reinforcement of the column is there, it has to be made L into the footing. And this L is, this should be minimum 300 mm L. And from here to here, the L is development length LD. And you can get that LD values from this table, LD 60 times diameter. So this is the LD, and this minimum we generally provide 300 mm L in the footing. And we also need to provide the L to the footing reinforcement. Even this is also LD like this. From here to here, it should be LD. As a standard practice, generally consultant gives this L up to full depth minus cover. But if you want to optimize the steel reinforcement, then you can provide this LD from this face to till this point. So sometimes you may not require this L if LD is sufficient horizontally only. So that is the general practice, but you need to refer the structural drawings. As a structural engineer has a choice to provide this. Now, see, the reinforcement is generally given in the schedule. Transverse reinforcement along B. Along B means you can see this is the B. So along B means this is along B, right? So this is your reinforcement along B. And this horizontal, which is shown, this is reinforcement along L. Along L means this is L. So along L is, this is the along L. This is width. So along B is this direction. You can see here. And generally it is given in terms of spacing. So let's say longitudinal reinforcement means along L. Let's say we have a T12 at 150 center to center. So it is given in terms of spacing, diameter and spacing. Also, let's say transverse reinforcement along B. Let's say it is a T10 at 150. You see, it is as per structure drawing. It is given like this. So development length part is very much important in this. How much should be the L? And you should know how to read this. What is along L and along B? Then there is a PCC below the footing as per given in the drawing. Generally 75 mm minimum PCC is required. Then this reinforcement, column reinforcement, we will go. This is the plinth beam. Generally in RCC building, we have a plinth beam or tie beams. It has to go till the up, and then as it goes in the upper floors, then this should be the lap location. Either staggered lap like this or lap at one location. So these are the general details for the footing. And yes, we have such kind of drawings even in the column footing details. That means how many floors are considered in the design of building. In this case, let's say for this drawing, this is a plinth level. So it is a first floor, second floor, third floor, fourth, fifth floor, and sixth floor, let's say. So this building is designed for 6 floors. So for that, the columns and footings are designed. So you cannot extend additional floors without permission of structural engineers. So generally, whenever they mention this, that means it is only designed for these 6 floors. So that is the case. So you should take care in that case. And then there are structural nodes given. So we have seen this in beam and slab session last time. So all other details are same. All dimensions are in mm. Then grade of concrete. The important note here is you should mention the bearing capacity considers, net safe bearing capacity consider for the design of foundation. So this is the important note for column and beam details, especially column and footing details. So in this case, it is a 30 ton per square meters. Many times consultant gives SBC in ton per meter square. Ton per meter square. In design, we use the SBC in kilonewton per meter square in structural design. So that means if it is a 30 ton per square meter means it is 300 kilonewton per meter square into 10, let's say. Then all other things are then maximum 50% lapping should be done at any section. And if you want to do lapping at one location, then 1.3 LD will be the lap length. Then for column 40 mm cover, for footing 50 mm cover. Then de-shuttering period is also given for columns and walls, not for beams, 24 hours, 1 day we can say. So it will be applicable for footing, vertical raft reinforcement, say shuttering also. So vertical shuttering for the footings here, whatever we provide formwork here, it can be removed within 1 day. So this is the total detail for columns and footings. So thank you for watching our videos. For other basic concepts, please refer other videos. And to know more about upcoming technical videos, please subscribe our channel. So thank you all.